Video today, B.4, Fibonacci numbers. All right. For this part, let's solve the problem, how to find Fibonacci numbers. Problem 12, calculate Fibonacci numbers. So I feel most of you should hear of this number, right? Yeah, Fibonacci numbers, very famous numbers. Yeah. Given recursion formula, base case is f0 equals 0, f1 equals 1. Then from there, we use a very simple recursion formula to generate all the remaining Fibonacci numbers. Yeah. It is very simple, but it has large number of beautiful properties. Yeah. So mathematicians, at old time, hundreds of years ago, so they like to study Fibonacci numbers. Yeah. All right, so here we want to study Fibonacci numbers to tell us some interesting methods, ideas, and rules. Yeah. Those things. Yeah. All right, so you can see if you apply the recurrence formula to generate sequence of Fibonacci numbers, can you find any rule? It is very hard to observe any nice rules here. Yeah, very hard. Yeah. So that means by observation, nobody can write the general formula of Fibonacci number by observation. Yeah. So you have to use some advanced method or tools to solve the problem. Yeah. So that's why for this lecture, we just give you introduction. Yeah. In our next class, we will use several lectures to completely solve this problem. Yeah. It is a complicated problem. Yeah. All right, so our plan, we solve in two different ways. The first way, solve it algorithmically. We use computer algorithm to find a solution. Yeah. So we write a computer program to implement some algorithm to find a solution. That's one. Second, the harder part, solve it mathematically. Okay. So we need to derive a math formula. So that part is extremely hard. Yeah. So we need to do a lot of mathematical development. Yeah. All right. The first part easy. So let us write a recursive function definition. Yeah. So here, recursive. For the base cases, easy. After the base cases, we just call the function recursively. Yeah. So we get a solution. We find the numbers. Yeah. But the question is, we want to see if it gives us a good solution or not. Yeah. That is important. When we study our algorithm, after we get a solution, we need to ask ourselves, is it a good solution or not? Here we do the same thing. Yeah. All right, first, no problem. This function gives us the correct answer. So that's no problem. Yeah. All right. The question is it a good implementation? That means even if it is correct, is it fast? Is it fast enough? Right? Yeah. We need to answer that question. Efficiency. We look at the question from the efficiency point of view? Yeah. Answer is, it is a horrible implementation. That means this implementation is extremely slow. We cannot tolerate the poor performance of this function. Okay? Yeah. Later you will see how poor it is. Okay? You will see how poor it is. Yeah. Because I will assign you your first programming project, this problem. I ask you to compare different methods to calculate the Fibonacci number. Okay? Yeah. Compare efficiency for two different algorithms calculating Fibonacci numbers. Compare which one is faster, which one is slower. All right, yeah. So that's the project plan. Yeah, we will do that soon. Yeah, okay, all right. Question, how bad is the algorithm? So we try to see it. Before we do our experiments, we want to see a little more information on that part. Yeah. Another question, can we improve it? If we find it is not quite good, can we do a little better? Yeah. So those questions we need to answer. Yeah. Yeah. All right. So let's continue our discussion. Yeah. Here, how to see why it is not very good. So we want to see that first. Yeah. We draw a recursion tree. Yeah. We want to see that problem visually. Yeah. We want to get some visual evidence to convince ourselves it is not a good method. Yeah. It's pretty easy. Yeah. So let me draw that tree. Yeah. Let's start with fiber of 6. Yeah. We do not need to calculate too many Fibonacci numbers. Yeah. Just enough. Okay. Fibonacci number of 6. Yeah. In order to calculate based on our function, the definition of our recursive function, we need to calculate fiber of 5 and a fiber of 4. Okay. In order to calculate fiber of 5, we need to calculate fiber of 4 and a 3. Yeah. Fiber of 4, we need to calculate fiber of 3 and a fiber of 2, and so on. Okay? So you keep going until you reach the bottom. At the bottom, you reach the base case. Okay? Yeah. After you reach the base case, you stop. Yeah. Because you can plug in the initial values for your base cases, then you're moving up, then you get the value of the top one. Yeah. So, yeah, that procedure. Yeah. But if you look at that, what's the problem? Try to observe. Can you find any rule there? Something that make this whole thing not very efficient? Can you see that? Okay. Yeah. Here, I just pointed out when we do the observation, we find a lot of redundant calculation. Look at fiber of 2. You do it here, then you do it another place, right? Fiber of 2. You calculate many places. Why you need to calculate so many times, right? That's the redundant calculation. Okay. That problem makes the whole algorithm not efficient. That's the reason that, when you think about it, you have a big tree or big fiber number. Think about, how about you try to calculate fiber of 100? So that's a big number. Can you imagine how big is the tree? The huge tree you will have. How much redundant computation you need to do? A lot. That's why it is a horrible method. Yeah. All right. Next, we want to look at the improvement, right? Yeah. How to improve it? Yeah. Here, I like to give you 2 methods to improve it. Yeah. The main idea is you want to remove the redundant calculation. in your improvement. Yeah. The first one, very simple. Yeah. First one, we use iterative algorithm. We do not use recursion, we use iterative way to solve it. Yeah. The code is like this, just a for loop. You start from the base cases, then you use a for loop, then you do iterations going up, okay? And finally, you get the answer. You can see, if you do it this way, no redundant calculation, okay? So each Fibonacci number anywhere in your array, you only calculate it once. That's it, only once. So this method should be very fast. It should be much faster than the previous recursive one. Yeah. All right, so method 2. Yeah. Method 2, we still use recursive algorithm. We just remove the redundant computation, that part. If we can do it, we can still use the recursive algorithm, right? Yeah. So that's the first thing. Second, we use an array to store calculated values. Yeah. How do we remove the redundant computation? We store the Fibonacci number values. If we already calculated, next time when we need to calculate the same value, we don't calculate. We just retrieve from the stored values. Yeah. Retrieve and use. We don't do the calculation. That's the key idea of this method. Key idea. Yeah. Make sure no values is calculated more than once. So in this way, we guarantee each value is only calculated once. That means no redundant calculation. Yeah. That's the idea. But how do you make it happen? Right? It's not easy to make it happen. Yeah. But if you do some careful arrangement of your data, you can do it. Yeah. Here, let me show you how to do it. Yeah. We store the Fibonacci number value in the F array. Yeah. Here we use a simple array, okay, to store that. Yeah. Then we write this code. Okay. When you need to evaluate Fibonacci number and I, any integer, positive integer I, all right, yeah, you check the known array. Yeah, we create an array called a known F. Yeah, so you know the meaning. The known Fibo values, known. Yeah. If we store a Fibo number in that known array, its value is greater than 0. It's a greater than 0. You don't need to calculate. You just return that value. Okay? We avoid redundant calculation in this way. Yeah. If it is unknown, yeah, because if it equals 0, it is unknown. Then you do the calculation. Then you do the recurrence way to calculate it. This time you can use the recursive call. It's okay. Because of this line, we guarantee there is no redundant calculation. Yeah. Yeah. All right, so then, yeah, so finally, if you reach the bottom, then, because if this is the first time we calculate it, yeah, so you assign this S value in putting this array, you store it. Then you also return to the function that make this call. Yeah. All right. So this idea is very interesting. Yeah. First, if we compare this method number 2 with number 1, definitely number 1 is much easier than number 2. Number 2 is much harder. Yeah. If you do that comparison. But number 2 has some very important significance in our algorithmic theory. Very important. The number 2 method corresponds to a very important idea in algorithm called dynamic programming idea. Yeah, so it's in our chapter 8. Yeah, dynamic programming. This is an important topic, and we will cover dynamic programming topic in our module 7. Second to last module, module 7. The whole module we will talk about dynamic programming. Here we can treat it as a first view or a simple introduction to that dynamic programming. So the basic idea for that, no repeated calculation. Okay, all right. But at this point, I do not want to go too far on dynamic programming. Okay, yeah, because in our module 7, I will discuss the whole theory from beginning to end in a lot of details. Yeah. All right, so that's all the 4 videos for today.